Did it start yet? Okay, it started. Hi, this is Mrs. Sloan, and today this is Honors Biology Review, Chapter 13, Immunity. Let me preface this with this is a brand new computer and it doesn't have all the settings exactly right, so I might have to kind of fiddle with things as we go, so hopefully it will work. And we'll go. There's only 11 of you today? Oh, there are. How sad. Okay, so let's go over. Can you answer the following for chapter 13? So just read through those. Hi, my friend. If your son becomes available after school, they gave me a new computer and it's a little bit jacked. I can't get it to do everything I need to do. It would be awesome because he helped me last time. Thank you, thank you, thank you. So glad we recorded that. Okay, did you read through them all? Okay. I have to click here to get it to go. All right. So circulatory system we already studied, and we know that's one set of fluids, right? And the lymphatic is another system of fluids. Where do the fluids come from that are in the lymphatic system? From your circulatory system, right? Remember what happens at the capillary bed? At the capillary bed, you have hydrostatic pressure and osmotic pressure. And the hydrostatic pressure forces fluids out at the capillary bed, and the osmotic pressure draws fluids what? In, right? And we always push out a little bit more than we can recover. So that is recovered by your lymphatic system, and it goes in the lymph capillaries and the lymph veins, and then it's venules and then veins, and then it's returned to your circulatory system. Do you remember where? What's it called? Oh, okay. It passes through a lymph node. I'm glad you said that. Passes through a lymph node first, and then it's returned at the subclavian vein. Do you remember that part? All right, so that's how these two systems are engaged. Now, at this point, you've learned already about the innate and the adaptive immunity, yes? And can you see why it would be important for the police force or the Navy SEALs to hang out in the lymph nodes? Because if you patrol the lymph nodes, those are like the border crossings, right? All fluids are going to have to pass through a lymph node eventually. And so that way you can just monitor those fluids and instead of trying to get everywhere in the body, all right? Questions on that you want to ask me? Sorry, I can't see anything on this computer. I can only see it here. So here, this kind of reinforces what I just mentioned. You're pushing fluids out. This is a review of chapter 12, and then you're drawing fluids in, but there's more pressure going out than in, so it needs to get picked up by your lymphatic system. These are the three functions of the lymphatic system. What I just discussed, absorbing excess tissue fluid. This is the one people forget a lot. Like if I give you like a map question where you have to pick more than one, is absorbing fat at the small intestines and then producing lymphocytes. Who are your lymphocytes? Your what? T cells and B cells. And then remember the natural killer cells? They're technically under the umbrella of a lymphocyte because the natural killer cells were supposed to go to the school of thymus, and then remember they dropped out, right? And thank you, Nikki. And so they're technically also a lymphocyte. All right, now, poor little eviscerated girl, we can see 4 main organs. You should know what each one does, right? We know that all cells from your blood come from where? Remember? Bone marrow. Good. All your blood cells come from your bone marrow, but B cells mature in your bone marrow, and that's why they're called B cells. T cells are born in the bone marrow, but they go and mature in the thymus gland. Okay. Then your spleen's job is to filter and monitor your blood, right, in your circulatory system, and all the multiple lymph nodes. You have one spleen, but you have multiple lymph nodes, and they are supposed to filter your tissue fluid. Okay, so you want to have those down, each of their jobs. T cells mature, B cells mature here in the bone marrow, filters blood, filters lymph. Now, there are other organs like your tonsils and Peyer's patches in your small intestines that will do that, but those are the 4 main ones. All right, now, when we think about immunity and protecting our body, Job one is just not to have any pathogens in our body that we even have to deal with. So that's why we have our what? Skin. But there are areas where we need to interact with our environment, like to get oxygen and to get food and to get rid of waste. So those areas have to be protected in other ways. So things like breathing, in our nostrils, we have hair. Things like eating, we have antimicrobial agents in our mouth. If it goes to our stomach, there's a really low pH there. We might have hairs and things in our ears as well. And those are all trying to keep things out of our body, trying to keep things out of our cells. Now, if they get through and get into our cells and tissues, right? And it will trigger a response. And the part that's triggering it is on the surface of these pathogens are called antigens. And antigens are what trigger your immune response. That's how we know stranger danger. And within our first initial response, we have our innate immunity, and that immunity is the same in all of us here in the room. It's what we are born with. And then we have our adaptive immunity, which is due to the experiences we've had. Your inflammatory response is primarily your innate immunity. But if you've had that same pathogen before, right, then you have what floating around in your blood? Antibodies, right? And antibodies can work in conjunction with our innate immune response in order to amplify it a little bit. So for instance, if you're allergic to some sort of plant that's starting to pollinate right now, you might respond, a little bit uncomfortably at first, but if you have some strong allergies, the next time you're around that plant, it'll be a little bit worse and a little bit worse because you have what? Memory cells and antibodies in your body already. Okay, so an inflammatory response is normally a good thing because it's triggering that there is a problem and it means things are going there to fight it. The problem we have is when that inflammatory response causes secondary problems like anaphylactic shock or inability to breathe, right? Sometimes we try to tone it down. That's why if you get an injury, like you twist an ankle, you might apply ice to it so you can decrease the swelling, right? Those are all parts, though, of your inflammatory response. The swelling, right here, we talked about histamine, if you recall. Histamine, do you remember who secretes that? It's part of your innate immune response. Yep, mast cells. Mast cells release histamine, and they make your blood vessels right here a little bit leaky, and then that enables the fighters to get out there more readily to do their job. It can also cause you, when you have extra fluid out there, it can be painful. But pain is a sign that you have a problem, and maybe you'll protect it or do something with it because you're aware that you have an injury of some sort. Okay. Everything on this page, are you feeling comfortable with? Okay. And do you need the code, sweetheart? Okay. And then you are so awesome. I literally just texted your mother. Did she already text you?
I literally just saw her.
Okay, you are so awesome. I am currently recording this right now for YouTube for the kids that can't come to the review. Are you going to be here very much longer?
Oh, I'm here till 3:30.
Okay, we will be done in like maybe 15 minutes.
Cool, I'll come back.
I love you. Do you need a power bar or anything? I have them in my fridge.
No, I'm golden. I need a cut weight anyway.
Well, you're perfect in my eyes. Thank you very much. All right. So here is like the steps of, you feel so special when you like have a problem. Did you see how fast that got handled? I'm like, I feel very special. Okay, so here we can see that inflammatory response. We want to recognize all our players right here. When you have a wound right here, bacteria might get in there. So we want to deal with the bacteria, but also if we have a wound, we might be what? Like what I tried to do when I cut off my finger or tried to cut off my finger. I was bleeding, right? Yeah? Okay. So what are the blood platelets going to do? You're going to clot your blood. Going to clot your blood to try to stop that part of it. Now, the bacteria, who got in before we could reestablish the barrier? Because now I have a barrier kind of here, right? So whatever got in at that point, then my immune system needs to take over. So right here, you can see a mast cell. And what is it secreting here that's labeled number 3? What is Histamine. And histamine, this is called vasodilation, but it's making your capillaries leaky. It's creating a little bit of space between the endothelium, so cells like a neutrophil can get out. Neutrophils are most numerous, and they are first on the scene. First on the scene. And what's this right here? Neutrophils secrete factors that kill and what? Degrade pathogens. So that they're fighting. You have macrophages. What do macrophages do? Yeah, they consume, and after they consume, they display it. They're one of the antigen presenting cells, and they're like saying, hey, any virgin B or T or memory cells recognize this pathogen because we have a problem, and it wants to stimulate those cells to respond. Cytokines. Do you remember the cytokines we talked about? Interleukin and interferon. Right? Interferon is an infected cell, just a singular cell that is got viruses in it, and it's warning others, hey, there's viruses in it there. That's interferon. Interleukin is like the fire alarm, and it's saying, hey, everybody come here. It motivates everybody to fight more. It's like they just, drank a Gatorade and they have a lot of energy. They will want to fight. Okay? This is your inflammatory response. Now, when I first taught you this, we didn't know about the adaptive immunity, but antibodies can help with all of this too. Remember the complement system where you drill holes into foreign? So antibodies who have met that guy before can assist with that process. So the two will overlap. Okay, and then here, the two types of adaptive immunity, they're good because they both serve different purposes, right? The antibody mediated, what they're trying to do is all the free floating viruses and bacteria that are out in the fluids of your body, they're trying to tag them. What are they trying to tag them with? Antibodies, right? Because antibodies will disable viruses so they can't get in your cells. They will mark cells for destruction. Macrophages want to eat things that are covered with antibodies. They can stimulate the complement system. So they attack the free floaters. Whereas your T cells, their target are your own body cells that have been compromised. And so you cannot have that, in perpetuity, because what would happen is they would just keep invading your other body cells and making more viruses or whatever, and then getting it released, and you would become overcome by that. So what they'll have to do is, if your body cell has a virus in it, you cannot help but display. And if you're a regular body cell, you will display on an MHC1 and you are done. Who's going to come kill you? Probably. What kind of T cell? What did we call them? Yes, you're saying it right there. Cytotoxic T cell is going to probably come and kill you, right? Now, that macrophage we saw earlier, when he displays it, he's a champion. He's displaying as a winner, not a loser. And he will display on an MHC2, and I will help you, right? Like a helper T cell will come and help release even more cytokines and get the B cells to release more antibodies so you can increase your attack. Okay, two different ways to fight: free floaters and cell to cell. And we know they're both stimulated in different ways, right? To stimulate your B cells, your virgin B cells, you need to come in contact with the actual pathogen. Your B cell needs are very, very specific. That you have, for all the pathogens in the world, you have maybe 1 to 2 cells that can recognize them total. And that B cell, once it has been triggered, it's still, if it's a virgin, the B cell cannot do it on its own. It cannot start making a clone army. It has to agree with the T cell, right? And how do we trigger a virgin T cell? Do you remember? The dendritic cells, the macrophages need to display that pathogen on an MHC2. I will help you, right? That will trigger a T cell. So the way I try to think of it is, B cells attack free-floating viruses and bacteria, so they are stimulated by free-floating viruses and bacteria. Do you see the logic of that? And then T cells fight our body cells that are bad, so they must be stimulated by another body cell. It's consistent, okay? So here's your B cell, and this is showing you that virgin B cell. It has to come in contact with the pathogen, and it will then make a clone army of cells that secrete antibodies. What's the name of the cell that secretes antibodies? Plasma cells. And you're going to remember that because it's going to secrete the antibodies into the plasma, the liquid portion of the blood. Remember that? And then once it's in there, it can get everywhere in your body, right? Because at capillaries, there's that exchange, and antibodies can cross that. Okay. And that's your clonal expansion. What's the other cell will it make besides plasma cells? It'll make what? Memory cells. Now, once the infection is over, the only cells that get to stay alive are the memory cells. The plasma cells have to commit what? Apoptosis. Because if you kept those plasma cells in your body, a million clone army, you would have like leukemia, right? That's why we need them to commit apoptosis, and we have memory cells for a faster response next time. Does that make sense to you? Okay. And then here, I wanted you to see all the different things. I added a new picture over here on the right for you. I'll walk you through it so it's not intimidating. But we already saw this agglutination, because antibodies have how many arms? 2 arms, right? We talked about how there are different classes of antibodies based on the heavy chain down here. And I told you didn't need to know them all. I did mention that IgG, immunoglobulin G, is the most common one. That's the one we're looking at here. But I believe one of your additional objectives wants you to know about IgE, and that is the specific antibody that embeds itself into mast cells to trigger those mast cells to release what? Histamine. Good. Okay. And then when antibodies are on pathogens, it makes macrophages want to eat them more. All right. Then this little chart over here, you can see B cells, and it's come in contact with the microbe. So it's releasing these antibodies. Look at all the different things that it can do, right? It can neutralize microbes. It can attach to this. Remember when I told you the antibodies can be called opsonins as well? Do you remember that? So it can attach onto one of those so that it gets eaten. It can increase phagocytosis. It can increase inflammation. It can be part of the complement system. So all of those things come as a result of antibodies. Okay, questions or concerns on that? Okay. All right, now let's talk about T cells and cell-to-cell combat. Up here, this has to happen. A dendritic cell, a macrophage, has to eat something, feed it, and as a champion, show it, and it shows it on an MHC2 to a virgin T cell. And then that virgin T cell will grow and divide into 3 cells. What are the 3 cells it'll make? Cytotoxic T, which fight. Helper T, which help. And then memory cells for a faster response next time. Good. Am I going too fast? I feel like I'm just flying. Are you okay? You would tell me? Okay. All right. So then we differentiated between your safe and your out. This is just reinforcing MHC1, displaying it. What kind of cell is going to kill this infected cell? Cytotoxic T. Remember how we leveled this up because you're so smart? And here in MHC2, what kind of cell is going to help it? Helper. I won't quiz you on CD4s and CD8s, but I know you're going to remember that because it's stabilized with CD4. I am for you, not against you. And if it's stabilized with the CD8 protein, you're going to get 8. Good. Any questions on that? So quiet. All right. Then this was just that big picture. Just scan it real quick and see if anything's scary to you. Are you good? Okay. All right. And then I added this one in here for you. Again, don't be afraid by it. We already learned all of it. It just kind of puts everything in perspective. So here's your stem cell. This would be in your bone marrow. Okay, if we go down here, you're not going to have to memorize myeloid, so don't worry about that. But from some of your bone marrow tissue, you're going to get red blood cells. And what is their job? We already learned that. Carries oxygen. You're going to get, you don't have to memorize that word. This is what I want you to know is you would get platelets. And what do they help? Blood clots. And that's just a megakaryocyte that will form those. Over here, we have monocytes. That's how they sneak out of your capillaries. Then they grow into great big old macrophages. And what are they going to do? Engulf. So this is one of your antigen presenting cells. And then this group of granulocytes, I pointed them out to you, but the one that I want you to know is neutrophils. They are first on the scene. I always remember that because they are numerous. So they are first on the scene. Okay, if we transition up here to your lymphoid stem cells, we talked about T cells that have to go to the school of thymus, right? And they're going to do cell-to-cell combat after they graduate from that school. If they are a T cell and they don't graduate, they become natural killer cells. Remember that whole video? Okay, and then we have B lymphocytes, which can form plasma cells, which make antibodies. Both of these will also make what? Memory cells. And the additional one here, it could form a helper T cell. Good. Okay, questions on this diagram? Just trying to put everything on one page for you here. Okay, and immunity. It's what you're born with, like the inflammatory response. Okay, then acquired immunity, two different ways. You can get exposed to that illness, and in 10 to 14 days, you will have your own memory cells in 10 to 14 days so you can fight that infection, or you can trick your immune system with an immunization. So you don't end up getting sick. You get something that will trick your immune system into thinking it's being exposed to that pathogen. Maybe you expose it to just the antigen, or you get some mRNA to make that antigen, and then you will develop all the memory cells, etc. If you're an emergency or a newborn, then you're going to have passive immunity, which means it's not going to be there for you in the future. It's passive. It's there in that moment. And through your breast milk, antibodies will be passed. Do you need me? Okay. And then artificial is where you go and get a shot, like a gamma globulin shot. And okay. Oh, gotcha. You get a gamma globulin shot, and that is borrowed immunities from somebody who has already had the disease. Or have you heard, like with the coronavirus, monoclonal antibodies? Okay, so in that situation, they've taken a cancer cell, infused a cancer B cell, and they're getting it to just churn out antibodies against the virus, and then you can get a shot of just those antibodies if you're starting to get sick and they're trying to control it. Okay, and when it goes, oh, I forgot I have no touch. When it goes, oh, sorry, I forgot. This one's in here. Do you remember the cytokines? Those are cells that, like macrophages and helper cells, they can release cytokines. You've got the one that stimulates the immune response, and then one that is, hey, that would be, do you remember what that one's called? Interleukin. This is interferon. This is if you are infected and you're trying to warn others, and you get neighboring cells to destroy all their RNA and just put a halt on all protein synthesis on the ribosomes, because you could be manufacturing viruses. So it's best not to do any protein synthesis. Or maybe you're infected, so you should just commit apoptosis if you're next to me. Or it could activate and stimulate like other immune cells to fight. Okay, and then problems we can have, we have to be careful with donating blood, donating any kind of tissues or organs, because our bodies will fight against anything that's not our own and try to attack it and destroy it, even though we might need that kidney or we might need that blood. So we can be really careful on blood transfusions. We don't give anybody blood that will make their body angry. You could actually get away with it one time, but after that you will have memory cells and it'll cause problems. Okay, other issues we talked about is allergies. We mentioned that a little bit earlier. We talked about anaphylactic shock, which is a real, hyper response to an antigen that's wouldn't normally bother people, but for you and your body, it bothers. That's why you can't eat peanuts or can't get stung by a bee or whatever it might be. And then we talked about when our body forgets ourselves. That's a bummer. That's an autoimmune disease. And the two I asked you to know were lupus, where you attack your own body tissues, and then MS, multiple sclerosis, where you attack your own nerves, and then your nerves don't work to stimulate your muscles. And we already talked about tissue rejection. And that is the end. Okay, did I go too fast? Are you okay? You're very quiet. Except these two are laughing the whole time. So I'm like, do I have ketchup on myself? Okay, you all good? All right. Hopefully this recorded in a way that I can use it.